Hello everybody, it is the end of April 2024 and this video is to show you how to use an integrated development environment to create your programs in, for instance, in the C programming language, but it can also be used for other things, other languages. Now I've seen quite a lot, especially with beginning programmers, that they use or still use command line programming, meaning that they would use any kind of editor, maybe Notepad or something like that, and then in the Notepad write their code, then leave the Notepad editor and then compile the program and link the program by using just command line in a command shell. Now that is of course is all very well, then you start to appreciate what is all behind it, that you have the things like a compiler and you have a linker and how to build, how to link with external library files and things like this. But the problem with this is that imagine that your program doesn't generate the output that you expected it would generate. What are you going to do? How are you going to remove the apparent bugs from your program, so-called debugging? How are you going to do your debugging? That becomes a little bit complicated. Of course, the classic way is then to put in the middle, the poor man's solution, you could say, is to go and put all kinds of printf commands in the middle of your program, in case you're programming in C, or maybe write line in case you're doing Pascal or something like this, and then just print whatever kind of comments in the middle to see if your program actually arrives at the point that you would expect it would arrive. Or maybe you want to see the value of your variables at various places in your program, and you just put a printf statement and print the value of your variables. This of course can be done, but it's a little bit poor and very inefficient, because you constantly have to go out of the editor and to give again the command to compile and to build, etc, etc. And we're living in the 21st century now. We have these so-called IDEs, which can help you write code much more efficiently. You can simply, as I will show you in a moment, you can just run your program step by step and then inspect your variables, or actually see if your program goes to the part of the program where you expected it would go. So I'm going to use here a quite popular IDE, which is called Codeblocks. I myself use more CodeLite for the reason I was attracted to this by the name, because I like these kind of systems, these environments which are simple, because many of them they suffer from what is called feature overload, that there is so many functionality in these environments that you cannot find the functionality anymore that you're looking for. So I would always say keep it simple, and then later you can migrate to more complicated environments. But for the moment, the simplest one will do. So I use Codeblocks because it is quite popular, I've seen on the internet, and that's why I'm going to use it. The difference between Codeblocks and CodeLite is actually so little. It's basically more about which shortcut keys are used for what functionality. So let's get started. I will start by writing a simple program, and guess what am I going to what program am I going to write? Yes, you guessed it. I'm going to write Hello World, but just to have it different, I will write it in Dutch. So we'll say Ha die wereld. So you learn some Dutch also. And then I'm going to compile it, command line, and then we're going to increase it until we have something that is quite running, and it has some technical details, and then we're going to migrate to the IDE. So let's get started. We need a command shell because we're going to do everything command line, so we need a command shell, which I open here. As you can see, I have here Linux Mint, so we have here everything is command shell, everything is from Linux. And by the way, if you're wondering what is now on the background, this is aerial view of the islands of Malta. Very nice. If you can one day visit it, very nice place. I can recommend it. But let's continue. I have here a command shell in which I can now start the writing my code. So I need to go and use any Notepad kind of editor. So first I have to go into the directory, which I already prepared for us here. As you can see here, it is completely empty. There will appear, above me will appear the program. So I have to use a general Notepad kind of editor. So I will use here gedit. You can use any that you like, what you prefer. And I'm going to say my prog math.c. And as you can see, it opened me the editor. In this, I'm going to write hello world or HDWereld. So I need to use printf. Printf, then, as we all know, I have to include I'm going to use the library standard IO. And I have to include here the headers for this library. Please don't call it studio, because it is, which I heard also a lot, it is standard IO, and IO stands for input output, and because we're going to write output to the terminal, we actually going to use standard IO. Okay, as you know, in C we have to supply a function called main that returns an int, so let's do that, main. I'm not going to use the arguments here, and that is the nice thing about C, is that you don't have to always do exactly as supposed to, so I can just ignore, otherwise I would have to put here argument count and argument values to, if I want to also receive information from the users. I'm not going to do this. I'm only going to, as you know, printf. I'm only going to print hello world in Dutch, which is HDWereld. There we go. Oh, I also want a new line for better visibility. Now we have our program. Let me save it. And as you can see, indeed, it has appeared here in my directory. A C program, very nice. So I should go out here and compile here command line, but I'm going to do something alternative. I'm going to here start a new command shell window, and here I'm going to, because I don't want to constantly go in and out of this editor. So here I'm again in the same directory, and I'm going to compile GNU C compiler, and what I'm going to compile is myproc.c. And as you can see, no errors, and it has created here the file a.out, and a.out is in fact the executable file that I can run here now. Probably in Windows it would be here, would be called a.exe if I'm not mistaken. Anyway, everything that I say here is for Linux. For Windows it might be slightly different, but not much. Okay, so here I'm going to run this a.out, so current directory and a.out, and as you can see, yes, there it says HDWereld, hello world. Now we're going to complicate it a little bit because I will put some functions in there. Let's first start with writing a function that takes two arguments, two ints, and returns the sum of these ints. My sum int a, int b, and it will return the sum, return a plus b. Nothing special. I'm sure you have seen this one, these things 1,000 times before. Now we're going to use printf. An integer is for printf is called d for digit, and a new line, and then I do my sum. I want to have the sum of 2 and 3. It is passing by a value, so this value is then attributed here to the local variable a, and the value 3 is attributed to the local variable that is created b. Okay, let's see how far we go. Can we still compile this? Do we not have any errors? No errors so far. So far so good. And let me run it. Hey, there we have it, HDWereld, and we have the sum of 2 and 3 is 5. So the computer can actually calculate quite well. This is just a joke. Okay, let's now do a little bit more complicated, and let's do some trigonometry calculations. My trigon, and it will receive a double R, and it will return something complicated, the sine of the argument plus the cosine of the argument. Yes, very nice, very nice. Okay, now I also want to print it here. Printf. What do we have? A double that is called a long float in printf language. And what do I want? My trigonometry, what shall I put? The sine and cosine of 0.5. Yes, very nice. Let me compile it. Oh, we get an error. Oh yes, of course, because we have to include also, we're using some mathematical functions. We're using some mathematical functions like sine and cosine, and these are in the library which are called math.c. H. Okay, so far so good. The compiler didn't know it. Let me compile it now again. Oh, it still didn't know it because now the compiler knows it, but the linker doesn't know. For some reason, when you use the libraries of math, then you have to specifically tell the linker that you want to use to link it with these files, with this library. This is not done automatically. So what do you have to do? -lm linker option, please include the mathematical library when you're doing your linking. And as you see, now it runs. Okay, let's now run the program again. Where do we have it? There we have it. HD wereld 5, the sum of 2 and 3, and apparently the sum of the sine of 0.5 radians and the cosine of 0.5 radians is 1.357008. I will believe that, I will trust that he's doing his job carefully. So now we have classically a program. We have here our program in our directory and we have the executable in our directory, and that's it. If it goes wrong, I would have to put more printfs or something like this to see what is going on in my program. But let's now migrate this entire thing to the IDE called Codeblocks. Codeblocks, I was thinking roadblocks, I guess that is what they were inspired by. So we have to install this, and I go in Linux Mint here, I go to the software manager. I can select, then I can tell it to specify here Codeblocks, and there we have it. I double click on this and you can see this logo is quite inspired by Windows, I would say. Well, we will forgive them that. And then here there would have been a button install, and I would install it, but of course I already have done it. I prepared this video beforehand, so I installed it here yesterday, and then it is now in the menu item here, programming Codeblocks. Let me start it. Okay, so this is how it starts. The structure, the general structure of Codeblocks is like this, and like also CodeLite, is that you have a workspace. In the workspace you can have various different projects, and every project consists of a set of files that will consume together. They will actually produce then your executable. So we have to start here then in our workspace, we have to start a new project, and I can do this here by File, New Project. That would be okay, but you can also click here directly, create a new project. So this is what I'm going to do, create new project. And look at this, how nice this Codeblocks is, because not only can we use our C language or whatever, we can also use other types of project. Here, imagine, you can do even MATLAB, or you can do Arduino. You can write, you don't have to use the Arduino environment, you can do this here. Or the AVR, which is the microprocessor, which is standard in the Arduino. You can also write code for the microprocessor, or actually also assembly in the ARM language. Or what is it, Fortran libraries, or things like this. And you can see a lot of other things, Qt, Qt4. But what we're going to use a simple code console application, meaning that we get input from the keyboard and we get output to a terminal. So I double click on this, and there we have it. Now I have to say what kind of language we're going to use. It will see actually that what are the compilers that are installed. Don't forget that an integrated development environment does not include the compiler itself. It is just the graphical environment with the buttons to help you make system calls to do the compilation and to use the debugger. So the compilation, the compiler and the debugger have to be installed separately. This is not standard, but I had it of course already with enough C programming. I have the C compiler and the debugger, the general debugger. I have it already installed. So I just select here C. I don't want to do C++ today. I do C. My project, I will call it my proj. Why not? What's in the name? And it will create actually this directory in my Dropbox environment. Okay, I'm going to use the same compiler, the GCC compiler. Let's see if I have others. Oh, you see, a lot of other things you could actually choose, but I don't have them installed. I just used the GNU GCC compiler, which was the same that we used for this one here. So it should generate the same code actually. Okay, so it has created here in my project, it has created a directory with a file already. It has made a file which is doing exactly that. Hello world. Note that this is not my code. I didn't generate this because remember I wrote HD wereld. This is generated by this environment. It has already sort of supplied the main so that you can have a starting. You could actually compile this and see if this works. Where did it put this file? To show you, and then I will show you also later, in this, where all my projects are. And you can see here, there is this main function that is part that it has generated. The environment itself is generated. Well, I don't want this, so I'm going to replace this with my own code. Control A, Control C, and let me paste it here. This is my program, and now the real fun starts with the IDE, because instead of having to compile and writing GCC and whatnot, I can put here simply build and compile the current file. And I can also compile and link the current file. And I can compile, link, and run the current file. So let me first say here compile and link, and you'll see, yes, once again, look at this. Again, it doesn't know the sine and cosine. Although I have included the header, the compiler knows it, the linker doesn't know it. So once again, I have the problem with this linker, and a lot of you will have this problem immediately, and then you have to go online to find how this works. So I will tell you this to you now. You have to go to here to your My Project, and then say the build options, compile and link options, and it says here compiler settings, but also linker settings. And in there, other linker options, we can say -L, link, please, linker, also include the mathematics library. Okay, that done, it should now actually quite well. It should compile and link the current file. Yes, that is nice. So now we have our executable program, the same like we had here, which was called a.out. Now this is in this project, it is in bin from binary debug, and there we have it. It's now called my project, but it is the same. It's executable. We could run it, but we're not going to do this command line, of course. We're going to do this from within the IDE, and this is here. When you see here build, it says there run what we have just compiled, or what I normally do, of course, with just one button, F9, you can compile, link, and run your current program. So let me do this, F9, and then you see, well, actually you don't see because these letters are too small, but I can already tell you that is what is here. It is exactly, the output is correct, but let me show you then when you find these letters like me, when you find these letters too small, just go to your settings, environment. You can basically set up everything how you like it. If you want a red background in this screen or whatever, you want to have fancy text, whatever, you can do it. But you have to go, in this case, you have to go to settings, environment settings. And there it is. When you have a console application, it will launch a terminal. What terminal will it launch? It is, in this case, it's called Xterm. And this Xterm has, just like normal command line options, it has the options also to increase the font size. But I also want to change the font. So I say -F. The font aspect is called mono. I should write it correct. Monospace. That is the font I'm going to use, and the font size is 14 point. Okay, let me run it again, F9, and now you'll see, yes, now, dear viewers, you can see that it has the same, exactly the same output again. HD wereld 5, 2 plus 3, and the sine cosine sum is 1.357008, as we already seen. Very nice. It waits for me for the input, and there we go. Here on the bottom you get all your compiler and linker error messages, or if there are any, which is very nice. Imagine that I write here A plus C. Imagine I do like this, and I try to compile this with F9. It says there, okay, error, undeclared first use in this function. Not only does it show this to me in red to draw my attention, but it also actually then puts the cursor at the place where is the error, and it puts a red square in front. So it immediately draws your attention. You don't have to read in which line it is. It is already standing there and says, hey, look at this. Oh, what is wrong here? Okay, undeclared C. Oh, of course, yes, C I didn't declare. So I can now change this into a B, or I can change this into a C, whatever. One will do the other. And now I can run it again, and there we go. We have the same program again. So that's already immediately the first option that you can see immediately your errors in compilation. It will draw attention exactly to where it is. The second point is that now I can, so the first advantage is that you can do everything by very simple presses of buttons. The second advantage is that it will give you relevant errors and put the cursor at the place where the errors are. And the third is that now I can run the program step by step and inspect actually what, if it's going wrong, I can see where it is going wrong. Does my program arrive at the correct place? So let me show you how to do this. Of course, you have to have the debugger installed. If you don't have these options here now, means you don't have the debugger installed. You will have to do this and choose your favorite one if you want. But now I want to step my program step by step. So I can do step over or step into, as it's called. The first one, of course, I have to step into my main function. I cannot step over it because that would be just executing of the entire program. So I say here step into, and note what happened. It starts, it opens the terminal like normally, no output yet. This is some kind of a strange operating system pseudo error, which I always just ignore. But now it has stopped the program at the first line. It didn't generate, as you can see, it didn't generate any of my output yet. It is there waiting. It went back to my integrated development environment, and it stopped there at this line where I have this yellow triangle. It is waiting to execute this. So now I can say debug next line. So that's F7. So let me put this by F7. With F7 I will execute that statement. Okay, it has executed, just to show you. Yes, it has printed this. So far everything is going well. I can also execute this one, and you will see in the output it has here, it has written the 5. But now let's imagine I want to go into this function. I don't want to execute this entire line. I want to go into this function, so I want to stop it there. I can do again, go now, debug, step into, shift F7, and as you can see, it is now, the program has stopped here at line number 9, which is the first line of my trigonometry function. And now the advantage starts, because I can actually, what I can do now, I can see if this value, if r has the value that I expect. Imagine I have passed here 0.5 to this function, and this is created a local variable with name r, and it should now have the value of 0.5. So let me see if this is correct. If everything went correct, I can say here watch r. And as you can see, I'm very sorry that this is very small. I didn't find out yet how to increase the size for this video, but you have to trust me. If the resolution doesn't permit, you have to trust me that here is written r, and here is written 0.5, and here is written double, meaning that everything is correct. The value r is the correct value. So I can just continue and execute my program. Everything went well. Program is finished. I can actually stop the debugger, and everything went well. Imagine that now I have millions of codes, and I don't want to do this millions of times clicking on F7. I just want to run it until it arrives at this place. What I can do, I can just left click on this line of code here next to the number of the line. That's 9. So I click here, and then it appears a red circle, meaning it has a so-called breakpoint there. The program will run until it hits a breakpoint, and then it will stop. So let's again rebuild. Let's again run the program, and then it should actually I should, yes, okay. So now it is there. It has stopped. It has stopped at line 9, as you can see, a yellow triangle inside this red circle, meaning that it has stopped there at the breakpoint. And again, I can inspect the variables. Well, I hope you appreciate the advantage of this, because you can really stop the program anywhere you want and inspect if the variables have the value that you expect they had. If not, let's see, do step by step to see why it doesn't have this value that you expected. And in this way, you can increase your coding efficiency at least by a factor of 10. Trust me, in the beginning it's a little bit small investment, but this will rapidly pay back, and you will much faster do all your programming projects. So I hope you enjoyed this video. In the next one I will show you how to make your own library and to just compile it once and then forever never look back at this again. So see you in the next video.